Welcome to the Explainer. So today we're going to talk about something pretty incredible, the quest to build a network that can actually heal itself. I mean, think about it. We rely on the internet for literally everything, but it's this incredibly fragile, complicated system. So how in the world does it stay running? And what would it take to build a network that's so good at managing itself that we never even have to think about it? Okay, so to even start talking about self-healing, we have to get our heads around the sheer scale of what we're trying to heal. You know, the internet isn't just one big thing. It's a network of networks, this absolutely wild, complex machine. We're talking hundreds of thousands of separate networks, everything from huge global providers down to, your local university. And they're all stitched together, constantly passing data between billions of devices. It's an engineering marvel, for sure, and one we all completely depend on. And that really brings us to the heart of the matter, right? With so many moving parts, so many things that could go wrong at any second, how does this whole thing not just fall apart every single day? Well, the answer isn't some single brilliant invention. It's more like a long, slow journey, a kind of evolution, really, from people manually fixing things to the dream of a network that runs itself. So where does that journey begin? Well, it starts with the network's very first, kind of simple reflexes. We're not talking about conscious thought here. We're talking about built-in protocols, which are basically just sets of rules for how to communicate. These were the earliest, most basic forms of automation, and they were a huge deal because they let the network react to problems all on its own without a person having to run in and, manually flip a switch. Yeah, think about it like this. In the super early days, if a cable was cut and a connection between 2 points on the network went down, some poor administrator had to go in and manually reroute all the traffic. That's what we call static routing. And it was, you guessed it, super brittle. It broke all the time. The real game changer was dynamic routing. This is where the different parts of the network actually learned to talk to each other and adapt to changes automatically. All of a sudden, the network got way more resilient. And it's really cool to see how this actually works. So let's say a backhoe cuts a fiber optic cable somewhere. Boom, a link is down, a router right next to that break, we'll just call it router Y, it detects the failure instantly. First, it updates its own internal map of the network. Then it basically shouts out to all its neighbors, hey, that path is gone. And what do the neighbors do? They immediately update their maps, calculate a new best route, and start sending traffic that way instead. It's almost like a nervous system rerouting a signal around a blocked nerve. And this all happens in milliseconds. It's incredible. But of course, as these networks started to get bigger, and I mean, they absolutely exploded in size and complexity, these simple little reflexes just weren't enough anymore. The sheer scale of the global internet meant you needed human oversight. This led to a whole new field, a new discipline really, that was all about trying to manage the chaos. And that's where we get the formal practice of network management. And a huge piece of that is something called fault management. This is the totally human-driven process. Just picture it, a team of people sitting in a network operations center, a NOC, that classic room full of giant screens with blinking lights and maps. Their job is to just stare at that, monitoring the network's health, logging every little issue, and trying to respond everything from one tiny failed computer card to a full-blown, catastrophic outage. And believe me, the stakes were incredibly high. A look back at history shows you just how fragile this whole system could be. Back in 1980, the ARPANET, that's the ancestor of the internet, it had its first major crash. And get this, even as late as 1997, a single router sending out the wrong information was enough to knock huge chunks of the internet completely offline for hours. So even with those early automated protocols, keeping things running was this complex, stressful, and totally reactive job. So yeah, the problem was becoming crystal clear. The network was just getting too complex, too fast. It was starting to outpace our ability as humans to keep up with it. The only way forward, the only solution, was for the network itself to get a whole lot smarter. And this is where we start to see the first real sparks of actual intelligence. A huge step forward was the creation of self-learning switches. See, instead of an admin having to manually program every single connection, these new switches could just sit there and watch the traffic flowing through them. And over time, they'd automatically build their own map of the network. I mean, they were literally learning all on their own. So that leads us to the next massive leap forward. We're moving from just reacting to problems we already know about to proactively identifying threats that are completely unknown. These things called anomaly-based intrusion detection systems, they don't need a big list of known computer viruses. Instead, they just watch the network for a while, and they learn what normal traffic is supposed to look like. Then, if anything statistically unusual happens, they flag it. They can spot brand new attacks that nobody has ever seen before. The system wasn't just learning a map anymore, it was learning to recognize weird. And this is really where the vision for a truly self-running network starts to come into focus. One of the internet's pioneers, a guy named Leonard Kleinrock, he put it perfectly. He envisioned a network that wasn't just managed by simple rules, but by these intelligent software agents, little digital workers spread across the network whose whole job was to mine data, spot trends, and carry out tasks dynamically, all on their own. Okay, so that brings us pretty much up to today. So what happens when you take all these decades of automation, all this learning, and you combine it with the incredible power of modern artificial intelligence? Well, that whole journey we just took comes down to one really powerful question. After all that evolution, what if? What if we could finally take the human out of the loop for most of the day-to-day stuff and let the network truly finally manage itself? The modern answer to that question has a name. AIOps. That stands for AI for IT operations. And look, this isn't just one single piece of tech. It's really the culmination of everything we've been talking about. It's about moving from being reactive to proactive and now to being predictive. So, for example, an AIOps system might notice that a server is starting to slow down and predict, hey, that thing's going to fail within the hour. And before that can even happen, it automatically moves all the traffic away to a healthy server. It prevents an outage before a single user ever knows there was a problem. And the thing that really makes AIOps possible on a massive scale is a big shift in how we build networks, and it's called software-defined networking, or SDN. The simplest way to think about it is that SDN separates the network's brain, all the control logic, from its body, the actual physical hardware. This creates this programmable, centralized view of the entire network. It lets an AI system see everything, all at once, and make smart decisions for the whole system, not just one little piece of it. All right, so let's wrap this up. What does all of this actually mean for the future of the internet? And, for every single one of us who depends on it every day. There's this really powerful vision from network scientist Jennifer Rexford. She said the ultimate goal of a self-healing network isn't just about stopping things from breaking. It's about creating a network that is so reliable, so autonomous, so efficient that it just becomes completely invisible. It's just there, like the air we breathe, and it never, ever stands in the way of new ideas or valuable services. And that's really the thought I want to leave you with. For decades, so much human brain power has gone into just keeping the lights on, just keeping the network running. If we can finally automate all that, if we can make the plumbing, the infrastructure, just fade into the background, what happens then? What new applications, what new ideas, what new services, things we can't even dream of today, will finally have the room to grow and become visible?